Okay, in this video we're going to look at some more laws of exponents. I'm going to start off by looking at this particular example, which is 5 to the power 3, that whole quantity raised to the power 2. So that's a power of a power. And I'd like to figure out what exactly is supposed to happen so that I can write another rule down in my list of laws that I know. And from what we know about order of operations, we're supposed to do anything inside the parentheses first. So what exactly is 5 cubed? Well, it'll be 5 times 5 times 5. Now, if I wanted to, I could actually figure out what is 5 times 5 times 5. I'm going to leave it like that for just a second, though. Because this is some number raised to the power 2. Any number to the power 2 means that number times itself. So if we have the number 5 times 5 times 5 times itself, I should be able to write that down. 5 times 5 times 5 times itself. Okay, so the same base multiplied by itself 2 times. Okay, so I've figured out, use the power 3 first, I use the power 2 second. In this case, I think maybe I could have done those 2 steps in either order. In any case, just like the previous video, now we have a bunch of numbers multiplied together. We don't care about how the parentheses are written. So we can rewrite this as just 5 times itself a bunch of times. 1, 2, 3, 4, 5, 6 5s all together. Okay, so if we have 5 to the power 6, we want to see where did these numbers come from the original formula. We had a power 3 and a power 2. How do 3 and 2 get put together to turn into a 6? 3 plus 2 would be 5, not 6. So it's got to be 3 times 2. It's the only way that makes sense. So apparently this is our next rule of exponents, or next law of exponents. If we have a power of a power, apparently what we're going to have to do is multiply the 2 exponents together. So writing it as a formula, a to the m to the n power is going to be a to the m times n. Okay, I'm going to now talk about a couple of hopefully quicker examples that are actually going to be special cases of this problem from the last video. In particular, I'm going to look at what happens if m and n are the same number. So let's make up an example. Let's say a is 7 and m and n are both 3. So according to this formula, if a is 7, m and n are both 3, then the left side should be 7 cubed over 7 cubed. The right side should be 7 to the power 3 minus 3. Okay, and let's see what we can figure out about this. 7 cubed divided by 7 cubed. Even if I don't remember what 7 cubed is, it doesn't matter. Any number divided by itself, 12 divided by 12 is going to be 1. So the left side is just going to be 1. Everything cancels if you want to think about it that way. The right-hand side, 7 to the power 3 minus 3, this is a grouping. So the grouping, or parentheses, are supposed to happen before any other operation, and 3 minus 3 would be 0. So that means 7 to the power 0 is equal to 1. And you'll notice there was nothing really special about 7 in this problem. I could have used 12, or I could have used 32. Any number as the base here, I still would have gotten that when you raise it to the 0 power, you end up with an answer of 1. So that's our next rule of exponents. Anything to the 0 power spits out 1. Okay. The next one is also going to be a special case of this. It's what happens when the number m is 0. So instead of this thing being 0, what if this thing is 0? So again, let's make up an example. Let's see, I'll use a different number this time. I'll use 5 to the power 0 divided by 5 to the power 3 equals, according to this rule, the quotient rule, 5 to the power 0 minus 3. Okay, Okay, so let's double check that I copied this down correctly. My m is equal to 0, my n is equal to 3, and my a is equal to 5. Okay? And from what we just talked about, the rule we just came up with, anything to 0 power should be 1. So this numerator right here should be a 1. So I'm going to try and simplify both the left side and the right side so that just like this previous problem, this equation, which we've based on something we already know, is going to hopefully turn into something new and exciting. So 5 to the 0 power should be a 1. I'm going to leave 5 cubed alone for a second, the denominator here. Again, we have implied parentheses around the 0 minus 3, so I should do that first. And 0 minus 3 would be a negative 3. So we have 5 to the power negative 3. And this is actually telling us a hint of how we're supposed to calculate exponents that have negative numbers in them. So a negative exponent is actually going to mean you keep the same base, you keep the same exponent, but the negative turns into a positive, and suddenly it's in the denominator. It's a reciprocal. So we have one more rule we can write down. Again, nothing special about 5 and 3. We could have used any number. If you have a negative exponent, that's going to end up moving you to the denominator and giving you a positive exponent with the same size.